the automatic fine-tuning section. In black and white television sets, the fine-tuning can be out of adjustment by a considerable amount, with no apparent lack of picture or sound quality. However, with color TVs, a tighter frequency tolerance is necessary because the color circuits contained in the television receiver require precise tuning. Also, with the advent of TV remote control devices, automatic fine-tuning is a must for consumer convenience. Although the terms AFC and AFT may refer to the same stage, this tighter frequency lock distinguishes the automatic frequency control from the automatic fine-tuning. AFT, or automatic fine-tuning, is basically achieved with the Foster-Seeley discriminator and the varactor diode. As you recall from UCanDo's FM Part 1 video VT402, one of the methods of demodulating FM, or detecting frequency change, is performed by the Foster-Seeley discriminator shown here. In the television system, the Foster-Seeley discriminator is tuned to a higher frequency and receives its input from the video IF amplifier section. When the discriminator detects a rise in frequency, it will output a negative error voltage in proportion to the shift in frequency. If the discriminator detects a decrease in frequency, it will provide an error voltage of a positive proportion. The output of the Foster-Seeley discriminator follows the same basic reverse bias requirements of the varactor diode, but with a reversed and lowered amplitude. A common emitter amplifier is placed in between the Foster-Seeley discriminator and the varactor diode of the local oscillator stage. This amplifier circuit provides inverse DC amplification and the exact bias level required for the varactor diode to correctly offset the drift in frequency. Now, whenever the local oscillator or tuner drifts off frequency, the video IF amplifier will reflect this change, and the Foster-Seeley discriminator will respond by generating an error voltage. This error voltage is inverted, amplified, and adjusted through the common emitter circuit and fed to the varactor diode within the local oscillator stage. Integrated circuits are also used in automatic fine-tuning sections. Here you see an integrated circuit which completely replaces the Foster-Seeley discriminator and the common emitter amplifier circuit. This integrated circuit not only provides error detection through its two differential inputs, but it also provides proper amplification of the error voltage to the varactor diodes. In addition, this circuit may be very precisely aligned to the manufacturer's specifications, even more so than the Foster-Seeley discriminator circuit. In conjunction with the automatic fine-tuning circuitry, some television sets include additional features to help ensure tight frequency specifications. Temperature compensation devices located in the local oscillator stage are used to help stabilize the oscillator from ambient temperature effects. And power supplies are designed to maintain very accurate voltages, which would otherwise cause the frequency to drift considerably. We will now pause for a short review of the material just discussed. Automatic fine-tuning is better able to lock in on the appropriate frequency than the automatic frequency control, which is also called automatic frequency correction. A Foster-Seeley discriminator is sometimes used in the television receiver to detect frequency drift and generate an error voltage in proportion to this drift. Since the Foster-Seeley discriminator outputs a small inverted error voltage, a common emitter circuit is used to reverse and provide the proper amplification of this voltage. Integrated circuits are used in most newer television receivers for detecting, amplifying, and correcting errors in frequency drift. Varactor diodes in the tuner's local oscillator circuit use a correction voltage to maintain a stable operating frequency. Temperature compensation devices and very stable power supplies help ensure tight frequency specifications